For over 3 decades, the Soviet Union became obsessed with Venus, launching more than 20 missions to humanity's closest planetary neighbor. Between 1961 and 1983, Soviet engineers sent probe after probe to a world where surface temperatures reach 462 degrees Celsius, and atmospheric pressure crushes objects like a deep-sea trench. Despite catastrophic failures, the Venera program achieved historic firsts, including the first images from another planet's surface. But buried in classified reports were tantalizing hints of something extraordinary, potential signs of microbial life in Venus's hostile atmosphere. Today, we uncover what Soviet scientists really discovered on the morning star. The first assault on hell. The Soviet obsession with Venus began with spectacular failure. Venera 1, launched on February 12, 1961, was humanity's first attempt to reach another planet, but contact was lost after just 7 days in space. The probe sailed past Venus in silence, becoming space's first ghost ship. Soviet engineers, led by chief designer Sergei Korolev, refused to surrender to this hellish world. Over the next decade, they launched mission after mission, each one teaching them harsh lessons about interplanetary travel. Venera 2 and Venera 3 also failed, but Venera 4 in 1967 became the first spacecraft to transmit data from Venus's atmosphere during descent. The probe revealed crushing pressures and scorching temperatures that exceeded all predictions. By 1970, Venera 7 achieved the impossible, surviving Venus's surface for 23 minutes while transmitting temperature readings of 475 degrees Celsius. This success marked the beginning of the most ambitious planetary exploration program in human history, as Soviet scientists prepared to unlock Venus's deadly secrets. First pictures from another world. October 1975 brought humanity's greatest planetary exploration triumph. Venera 9 descended through Venus's crushing atmosphere and, against all odds, survived long enough to transmit the first photograph from another planet's surface. The grainy, black-and-white image revealed a landscape of jagged rocks and flat stone slabs, illuminated by the dim orange glow filtering through Venus's thick clouds. Venera 10 followed 3 days later, capturing more surface images from a different location. These photographs stunned scientists worldwide. Venus wasn't the molten hellscape many expected, but a rocky world with surprising geological diversity. Mission director Vsevolod Abduevsky noted unusual atmospheric readings during the descent, including unexpected chemical signatures that some Soviet researchers quietly interpreted as potentially biological in origin. The landers survived for over an hour each, far exceeding design specifications and proving that sophisticated exploration of even the most hostile worlds was possible. These historic images opened the door to more ambitious missions that would soon detect mysterious compounds in Venus's deadly atmosphere. The Chemical Anomalies. Soviet scientists discovered something puzzling in Venus's atmosphere that defied easy explanation. Venera 11 and Venera 12, launched in 1978, carried sophisticated gas chromatographs and mass spectrometers designed to analyze atmospheric composition during descent. The instruments detected unexpected organic compounds, carbon-based molecules that shouldn't exist in Venus's hostile environment. Dr. Boris Surkov, the mission's chief chemist, reported finding sulfur-bearing organics and phosphine compounds in concentrations that couldn't be explained by known geological processes. Most intriguingly, the probes detected rapid chemical reactions occurring in Venus's middle atmosphere, approximately 50 to 60 kilometers above the surface, where temperatures dropped to a more habitable 0 to 60 degrees Celsius. Soviet biochemist Leonid Mukhin argued these reactions showed signs of metabolic activity, the signature of living organisms processing chemicals for energy. Western scientists remained skeptical, attributing the findings to instrument contamination or unknown atmospheric chemistry. But classified Soviet reports suggested something more extraordinary. Venus's clouds might harbor extremophile microorganisms adapted to the planet's sulfuric acid environment. Life in the clouds. The most startling Soviet discovery came from studying Venus's upper atmosphere where, conditions dramatically improve. At altitudes of 50 to 60 kilometers, atmospheric pressure equals Earth's sea level, and temperatures range from 0 to 80 degrees Celsius, potentially habitable for extremophile life forms. Venera 13 and Venera 14, launched in 1981, carried biological detection equipment including microscopes and soil analysis chambers. The landers detected rapid oxygen depletion in atmospheric samples, suggesting active chemical or biological processes. Soviet astrobiologist Gavril Tikhov had long theorized that Venus's clouds could support sulfur-based life forms, and the Venera data seemed to support his hypothesis. The probes found droplets containing complex organic molecules suspended in the acidic clouds, including amino acid precursors and lipid-like compounds. Most remarkably, these organic materials showed isotopic ratios inconsistent with purely geological formation. Dr. Roald Sagdiv, director of the Space Research Institute, privately reported that the findings suggested, quote, active biological processes, end quote, occurring in Venus's atmosphere. However, the extreme secrecy surrounding Soviet space biology meant these extraordinary claims remained largely hidden from international scrutiny for decades. The Phosphine Mystery. Soviet atmospheric analysis revealed one of the most intriguing chemical mysteries in planetary science. Venera 15 and Venera 16 orbiters, deployed in 1983, used infrared spectrometers to map atmospheric composition across Venus's entire globe. The instruments detected significant concentrations of phosphine gas, or pH3, in the planet's clouds, a compound that shouldn't exist in Venus's oxidizing atmosphere. Dr. Mikhail Marov, the mission's principal investigator, noted that phosphine breaks down rapidly in the presence of sulfuric acid and should disappear within minutes. Yet the gas persisted at levels of 10 to 20 parts per billion, suggesting continuous replenishment from an unknown source. On Earth, phosphine is produced almost exclusively by anaerobic bacteria living in oxygen-free environments. Soviet microbiologist Alexander Imshinetsky conducted experiments showing that certain terrestrial microorganisms could survive in sulfuric acid solutions similar to Venus's clouds. The persistent phosphine detection became classified information, but leaked reports suggested Soviet scientists believed they had discovered the first evidence of extraterrestrial life. This finding would remain buried in classified archives until recent international missions rediscovered phosphine in Venus's atmosphere. The biological instruments. Few people know that Soviet Venus landers carried sophisticated biological detection equipment designed specifically to search for life. Venera 13 and Venera 14 included automated microscopes capable of magnifying samples 500 times to detect cellular structures. The landers also carried enzyme detection chambers that could identify metabolic byproducts produced by living organisms. Mission biologist Dr. Wolf Vishniak, working with Soviet scientists, designed experiments to detect microbial respiration by measuring changes in gas concentrations over time. The results were extraordinary. Soil samples showed rapid chemical changes consistent with biological activity, including pH fluctuations and organic compound synthesis. Venera 14 detected what appeared to be microscopic structures resembling bacterial colonies in atmospheric condensation samples. Soviet scientists also found diurnal variations in atmospheric chemistry that suggested day-night cycles of biological activity. However, contamination concerns and instrument limitations prevented definitive conclusions. Dr. Carl Sagan, who collaborated with Soviet researchers, privately acknowledged that the data was, quote, tantalizingly suggestive, end quote, of biological processes, but cautioned that extraordinary claims required extraordinary evidence that the harsh Venusian environment made nearly impossible to obtain. The temperature paradox. Soviet missions revealed a shocking truth about Venus's atmospheric layers that really challenged assumptions about planetary habitability. While the surface reaches 475 degrees Celsius, hot enough to melt zinc, the upper atmosphere tells a completely different story. Venera atmospheric probes discovered that between 48 and 70 kilometers altitude, temperatures drop to Earth-like ranges of -10 degrees to +60 degrees Celsius. In this so-called Goldilocks zone of Venus's atmosphere, pressure equals Earth's sea level and water could in theory exist as liquid droplets suspended in the clouds. Soviet atmospheric physicist Mikhail Avduevsky calculated that this habitable layer actually extends across Venus's entire globe, creating a planet-wide aerial biosphere that's even larger than Earth's total land surface. This discovery really revolutionized thinking about where life might exist in the solar system. Venera 15 and Venera 16 radar mapping missions detected atmospheric convection patterns, suggesting complex weather systems in this habitable zone. Most intriguingly, the probes found chemical gradients that appeared to be maintained by unknown processes, possibly biological ones. This temperature stratification meant Venus might harbor more habitable volume than any other planet except Earth, hidden within its deadly atmospheric envelope. The Coverup Controversy. The Soviet Union's secretive approach to space biology created decades of speculation about what they really discovered on Venus. Classified reports from the 1980s, released after the Soviet collapse, revealed that multiple Venera missions detected anomalous biological signatures that scientists just couldn't explain through known chemistry. Dr. Roald Sagdaev later admitted that Soviet space officials suppressed potentially groundbreaking discoveries to avoid international embarrassment if the findings proved false. Internal memos from the Space Research Institute described biological anomalies detected by Venera 11, 12, 13 and 14 that suggested active metabolism in Venus's clouds. The most controversial claim came from mission scientist Leonid Sanfomality, who reported finding moving objects in Venera surface images that appeared to change position between photographs. He interpreted these as possible primitive life forms adapted to Venus's extreme surface conditions. However, peer review and image analysis by other scientists suggested these were likely instrument artifacts or wind-blown debris. The lack of transparency around Soviet biological experiments means that potentially revolutionary discoveries may have been lost forever in classified archives, fueling decades of speculation about hidden evidence of Venusian life. Modern vindication. Recent international missions have validated many controversial Soviet claims about Venus's potential for life. In 2020, radio telescope observations confirmed the presence of phosphine gas in Venus's clouds, the same compound Soviet scientists detected in 1983 but couldn't publish due to classification restrictions. Dr. Jane Greaves of Cardiff University led the modern phosphine discovery, measuring concentrations of 20 parts per billion at 55-kilometer altitude, exactly matching unreported Soviet data from the Venera missions. This vindication has prompted scientists to reconsider other dismissed Soviet claims about biological activity in Venus's atmosphere. NASA's planned Veritas mission and ESA's Envision orbiter will carry advanced spectrometers to search for the organic compounds and metabolic signatures that Soviet instruments may have detected decades earlier. Modern computer modeling shows that extremophile microorganisms could indeed survive in Venus's cloud layers, feeding on sulfur compounds and carbon dioxide. The rehabilitation of Soviet Venus research has transformed our understanding of planetary habitability, suggesting that life might exist in environments previously considered impossible. Venus may indeed harbor the first confirmed extraterrestrial life, hidden in plain sight for over 40 years. The enduring mystery. The Soviet Venera program's legacy extends far beyond its technological achievements to fundamental questions about life in the universe. Over 22 missions spanning 2 decades, Soviet scientists gathered more data about Venus than any other planetary body except Earth. Their discoveries of organic compounds, phosphine gas, and atmospheric chemistry consistent with biological processes remain some of the most intriguing findings in planetary science. Dr. Sarah Seeger of MIT calls the Soviet Venus data the most underappreciated dataset in astrobiology, noting that modern analysis techniques could extract revolutionary insights from 40-year-old measurements. The recent phosphine confirmation has sparked renewed interest in Soviet archives, with researchers discovering previously classified spectrometer data showing complex organic molecules and isotopic signatures suggestive of biological activity. While definitive proof of Venusian life remains elusive, the accumulated evidence suggests our nearest planetary neighbor may not be the sterile hell world we assumed. As new missions prepare to return to Venus, they carry the hopes of finally answering the question Soviet scientists posed decades ago: could life exist in the clouds of our sister planet? The Soviet Union's decades-long exploration of Venus produced tantalizing hints that our sister planet might harbor life in its acidic clouds. From phosphine gas to organic compounds and unexplained chemical reactions, Soviet scientists detected phenomena that modern research is only now beginning to understand. While definitive proof remains elusive, the mounting evidence suggests Venus deserves serious consideration as a potential habitat for extremophile life. Which Soviet Venus discovery surprised you most? Drop your thoughts below. If you enjoyed uncovering these planetary mysteries, hit that like button, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible scientific revelations.